experimental study, the researcher conducts an experiment where he tries to see how one variable affects another variable. Data is actively being created.
Perfect. Thank you so much. That's excellent. Yeah, observational, you're not touching anything. You're just looking at things that have happened or are happening, but you're not involved at all. In the experimental study, you're getting in there, you're affecting things, you're putting things in different groups. You're in this group, you're in that group, you're giving different amounts of drug to somebody. You're changing things, right? So that's how those two are different. Observational, it could have happened years ago, and you're just looking at data later on, but you're hands off, totally hands off of it. Oops, wrong mouse. Here's an example of an observational study. Say I want to know if asking questions leads to better grades. I can observe several classes and note which students ask questions, and then later see what grades they have in the course. What are my variables in this, guys? So take 15 seconds, think about what questions, who am I surveying or asking, and what am I trying to find out about them? What am I asking them or about them? Just think about it for 15 seconds and I'll ask. Okay, so what am I trying to know about? Well, first of all, what is my sample? Who am I sampling?
Class.
Yeah, students, right? Right, classes, so students in classes. And then, what am I asking myself? What am I either asking those students or asking myself about those students?
Asking more questions for the grade.
Yep. So whether or not they ask, wait, what did you say?
If asking more questions correlates with the grade.
Okay, so you're one of the people in the class. So I'm asking you, hey, does asking more questions lead to better grades? Is that what I asked everybody? So there's 100 people in these classes, and I asked all 100 people. I asked them that question and said, hey, does asking questions lead to higher grades? Is that what I asked them?
It should be.
So what did I ask them?
If asking questions, what grade they got from asking questions.
So specifically, you're saying what grade they got. Okay, so I definitely asked them what grade they got. I asked myself, what grade did the student get? That's one thing I asked. What's the other thing I asked each student? Or I asked about each student? What was that?
Do you ask questions in class?
Do you ask questions in class? So those are the two variables. Do they ask questions, and what is their grade? So not the question, so that gets tricky. I'm not saying what question am I asking about the students. I'm saying what question am I asking the students? Do you see the difference there? And so what am I asking them? I'm asking them, what grade did you get, and did you ask questions? Now, here's the problem, cause and effect. I'm claiming that asking questions leads to better grades, but we're just observing. So we don't know which one causes which. Maybe students who get better grades ask more questions. So maybe the better grade part is what drives the questions, not the asking questions drives the grade. So that's the problem with observational studies. You cannot figure out which one causes which. There are some advantages to it, though. Adriana, do you want to go ahead and read for us?
Advantages to observational studies often occur in natural settings. No falseness of data since people often aren't aware they are being studied. Some variables would be unethical to experiment with, rape, murder, suicide. Some variables cannot be manipulated, left-handed to other genetic features.
Exactly. Perfect. Right. So I mean, maybe I want to know if if having coronavirus, that's probably a little bit harder. So there's a lot of different things that really are kind of, or like if if having an education leads to better jobs. I can't randomly pick people and say, you guys are going to get a college education, like it or not, no choice. You people, not allowed to have a college education, if you want one. You know, you got great grades in high school, nope, you can't go to college. You guys have to go to college, and then see what jobs they get later on. That's unethical, right, for example. For example, nope, that's good. All right, how about Janice? Go ahead and read this one for us. This is also in your notes. We're back to your notes. Make sure you guys are taking notes.
In an experimental study, the researcher conducts an experiment where he tries to see how one variable affects another variable. The independent variable is the one being manipulated, changed in specific ways. It is also called the explanatory variable because it explains why the dependent variable is the way it is. It is the cause, not the effect. The dependent variable is the one that is affected by the independent variable. It is also called the outcome variable since it is the outcome, the effect of the independent variable.
Perfect. Thank you so much. Right? So independent variable, dependent variable. The independent variable is the one you mess with. It's the one you change to try to have it affect the dependent variable. So the independent variable is the one that you're messing with, the one that you are altering in some way. Dependent variable, that depends upon what you did with the independent variable. All right, so here's your Jamboard. It's in the Jamboards, I think. I believe I copied it into all of them, yes. So go ahead, you don't have to worry about it. It's in all of yours. It's right there. So I need you guys to figure out what the variables are, first of all. So in other words, what 2 questions are you asking each person, or asking yourself about each person, not as a group, but each individual person, and then figure out which one's the independent variable and which one's the dependent variable. So go ahead and hop in and do that, and write on this board. Megan, what room are you normally in?
I'm normally in
3. You're in 3 today. And Laura, what room are you supposed to be in? 5? 7? Okay. Sounds good. 7. There you go. What's up with that? Room 8. They're all not joined. Oh, they're I see. I'm looking at old things. All right. Okay, so my question to you folks is this. Oh, I'm muted again. Okay. So my question to you guys is this. Who are my subjects? Who are the people who are in this study? Female undergrads, great. So I have female undergrads in the study. So my next question is, say they're walking out for the day. What questions am I asking these female undergrads as they walk out? Something. I remember a variable is something that varies. So in other words, it's not fixed; it changes. Think of it that way. Variables vary. So what 2 things am I asking about them that are, going to be different for each person, or maybe different for each person? Great, that's one of them. How many steps they could do in 90 seconds? Perfect, that's one. What's the other thing that I want to know about each of them that may not be the same as everybody else, that may differ from person to person?
That they have a number.
I don't have that in here. So something that I need to know about them. Mm-hmm. Exactly. What group they're in. So the two things I know about them is whether they're in this group or if they're in the other group, which group they're in. So what group they're in other words, were they told to increase your number or were they told to try your best? That's the one thing I know about them. The other thing I know about them is how many sit-ups they did. Which one can I control? What group they were in or how many sit-ups they did? The group they're in. I put them into a group so I can control that. That's my independent variable, right? So the independent variable is what they were told, right? Which group you're in, what you're told, and the dependent variable is the number of steps they're able to do. A lot of you guys had, right? There's another way of looking at it. The independent variable is what goal they were given, and the dependent variable is the number of sit-ups they did. Great. Okay, now, I'm going to read it for this one. Tate, go ahead.
All right. Counting variable is dependent variable that cannot be separated from the independent variable. For example, subjects put into exercise programs may also improve their diet, possibly improve their health in other ways, not due to exercise alone.
Perfect. Exactly. A confounding variable. It's something you can't separate out from the independent variable. A very, very common one that we've seen many times, so common in fact that they created a whole fix for it, is called a placebo. So placebo effect, so what they found was this confounding variable is, here's my control group. You guys, I want to see if this pill, helps with your cold. You guys don't get any pill at all. You're my control group. You guys get this cold pill. What they found was that just the fact that you get a pill makes you think that you're going to get better. So then you do better, you get better, just because you're given a pill, regardless of whether it does anything. So that's a confounding effect. So to eliminate that confounding effect, what they do is they give somebody a placebo, which is a fake pill, which makes them think that, oh, I must be getting better, even though this pill does nothing. So they get better, but the people with the real drug hopefully get get better a larger amount than the placebo group, and that's how they see what. Let me show you guys what I'm talking about. Right. So here's the placebo. Here's the control group. They raise this much because they just are taking a pill and they think they should get better. Hopefully the drug amount goes up this amount, right? They're going here, they go up here, and this amount is just because of the placebo effect, and this amount is the actual part that the drug is helping them. So that's kind of the idea of confounding variables. In this example, the fact that you get a pill at all makes you think you're going to get better, right? Just because you think you're getting something that should make you feel better. Zachary S., go ahead and read.
Great. Blinding is when subjects don't know if they are getting the real drug or placebo. Double blinding is when both the subject and the researchers don't know who is getting the real drug or the placebo. And replication is when the same experiment is repeated somewhere else, and the results are compared to see if they are the same.
Right. So blinding is obviously super important. You should not know whether you're getting the real drug or not. Double blinding is also really useful because the researcher might accidentally, react in a way that tells you whether or not you're getting the real drug, and you don't want to, know that. That's bad. Replication is also super important because, I do this experiment, and say I just happen to get a randomly good result. I flip a coin 100 times, and randomly I get, or 10 times, and I randomly get like 8 heads. I'll be like, oh my gosh, I can write a paper. Heads, probably getting heads is not 50%, it's 80%, right? It's something larger. But, I can't the problem is that I just got a randomly weird sample without knowing it. If I tried to replicate it, I probably would not get 8 heads again in a row, or not in a row, 8 heads out of 10. So if you can replicate it somewhere else, that kind of eliminates the likelihood that you randomly just got something unusual. So that's the idea. We'll talk a little bit more about that probably next class. Yep, Miriam, go ahead.
If it was an experimental study, can you control exactly what subjects you want to study and how to place maneuvers? Can you control and manipulate the independent variable?
Great. Yep. So experiment, you can control the independent variable, which means you can draw conclusions from it and say that one thing causes another thing. Other things, disadvantages, unnatural settings, so that may not, apply to real life, or if you do it to rats, that may not apply to humans. Hawthorne effect is when people act differently because they know they're being studied. People always act differently when they know they're being watched. Will, go ahead. Will S.
Wait, what did you start, please?
Just from the top.
Okay. Uses and misuses of statistics. Suspect samples. Is the sample large enough? How was the sample selected? Volunteer or convenient? Is the sample representative of the population? Pork clustering, for example, do use schools. Ambiguous averages. What particular measure of average was used? Why? Mean, median, mode, or mid-range?
Right. Oh, yeah, that's fine. Thanks. Right. So, average actually, when we think of average, when we hear the word average, we automatically think add them up, divide by how many there are, right? That's what everybody thinks. That is actually a mean, but the median, the mode, and the mid-range are also called averages or considered averages. So you could say an average bargain play makes, and you could use the mid-range instead, which would be totally inaccurate, right? It would give the wrong impression, I should say. It would be accurate and legal, but it would give the wrong impression. Changing the subject, which isn't really a misuse, but more of a manipulation of the audience. So a few years ago, there was this commercial, and it said, autism affects 1 out of 68 children. That scared the crap out of me. I don't have children, and I was still scared by that. It's scary idea. 1 out of 68. But if they had said autism affects 1.5% of children, that would not be nearly as scary, right? Even though 1.5% is slightly larger than 1 out of 68. It's just how we perceive it. Also, another thing that is misleading a little bit is detached statistics. Things say, oh, we have 1/3 fewer calories. Then what? A chocolate cake, right? They don't tell you. Sometimes they do, but if they don't, then it's troublesome. Implied connections. These are all things that aren't. You can't hold people to them, right? They're slippery. Studies suggest that some people may understand what this statement means in certain cases, or might help reduce, right? So studies suggest that some people may lose weight on an all-chocolate diet because it seemed like this one woman was losing weight on an all-chocolate diet, even though the other 99 people gained weight. It's not stuff that you can lock down into anything. They're not really saying anything that's firm. It's slippery. It's not legally binding. Misleading graphs, we'll talk more about the next chapter, and then loaded questions. Right, so those are questions that kind of lead to a certain answer. For example, do you feel statistics teachers should be paid higher salaries? Of course, you guys would all say, oh yes, of course, right? But if we said, do you favor increasing tuition so that colleges can pay statistics teachers higher salaries? Then, of course, you guys would be like, no, poor students, you can't do that. So, how you phrase the question matters. C, can you go ahead and read this one?
Order of questions. Questions are unintentionally loaded by such factors as the order of the items considered. Would you say chocolate contributes more or less to average weight? traffic 45%, industry 27%. When order reversed, results industry 57%, traffic 24%.
Right, so they totally flipped, just depending upon which one you said first. And there's no way of getting around that, right? The only thing you can do is ask half one way and ask half the other way and hope they kind of average each other out a little bit. There's some other common pitfalls. The main one is this. This is important. Serena, go ahead and read this for us. Oh, sorry, you have to unmute yourself first.
Including that one variable causes the other variable when in fact the variables are only correlated or associated together. Two variables that may seem linked are smoking and pulse rate. You cannot conclude that one causes the other. Correlation does not imply causes.
Causality. Yep. Thank you. So see how that's in red? It means it's really important. You can instead say, just because two things being related does not mean one causes the other. Or you could also say, without an experiment, you don't know which one causes which. In other words, correlation, in other words, two things that are linked, you can observe them being linked. You can't say which one causes which. The only way you can do that is if you do an experiment. So smoking and pulse rate, you can't say that smoking causes a higher pulse rate. It could be that a higher pulse rate, people who have a higher pulse rate are more nervous, and so that drives them to smoking. You don't know which one causes which. And that's the problem. The only way you can do it is if you did an experiment. If I said, okay, you guys have to smoke. I don't care if you're a non-smoker or not, you are forced to smoke. You guys, not allowed to smoke. Even if you have been smoking forever, you're not allowed to smoke. And then, after, 3 weeks or 2 weeks or something like that, then check their pulse rates and see what their pulse rates are. But the only way that you can have causality, say one thing causes another one, is if you do an experiment. And you randomly assign people to one group or the other group. That's the only way you can do it. So it's super important you realize that. Organizing data, let me go ahead and cut and paste this into the chat. Ooh, where's my chat? Okay. So everybody click on the Google Doc link I just sent you. Click on it, click on it. Are you guys all there? I should get on it as well.
Wait, can you please resend it? It went away.
You know what? I wonder if I used the wrong one. Hold on a second. Is that? Oh yeah, that is the right one, I think.
Oh wait, never mind.
Did I send you guys the right one? No. You know what? Don't go to this one. Go to this one instead. Try that one. Oh, is that the same one? That is the same one. Oh, I did something right. What do you know? Oh, that's the wrong one. That's totally the wrong one. Hang on a second here. I'm having a very not good spot here. I just did these this morning. Oh, hang on. It's a, how do I get to my Google Sheets? All right, in the meantime, everybody think about how many siblings you have.
0.
Okay, good. There we go. Okay. No, that's not it. I set these up. I swear to God I set these up. Oh, I know. Son of a gun. Try this again. Okay, good. So yes, everybody go here and go to the 5 p.m. tab down at the bottom. So can everybody see this tab at the bottom? It says 5 p.m. That's you guys. Click on that one. Okay, so it's by group. So if you're in group 1, fill in one of these blanks. If you're in group 2, fill in one of these. Doesn't matter, just pick one. If you're in group 3, fill in another one. Group 4, so forth. Everybody should be filling one in. We're in the 5 p.m. Make sure you're in the 5 p.m. tab. Don't be in the 2 p.m. tab. 5 p.m. Along the bottom. Click on that one.
Can we include ourselves?
Yes. You are part of your family. Or no, siblings. How many siblings you have? So no, you don't include yourself. My bad. Yeah. How many siblings do you have? So you can totally have 0 siblings. I'm only getting group 1. You guys are not participating at all. What's going on? Group 3.
For group 1, I have to download the app before I can actually edit the page.
You can't just. All right, tell someone else. Tell me what it is. What's your number?
So my number's 5.
5. That's fine. All right. Group 3. What's going on? Miriam, Megan, Zachary, Jamila. Yeah.
How do I know it's the 5 p.m. one?
Because on the bottom it says 5 p.m. There's a 2 p.m. which is over here. There's 5 p.m. which is over there.
Okay.
Huh? Okay.
Oh.
7:30 is over here. Oh, a lot of 7:30s. What's going on? Oh, that might be me. I might have done that. Okay. All right. Now, this is kind of neat. So this is our raw data. See all the data like this? Just numbers. This is raw data. Just the numbers as we have it. And then we can do stuff to it. So I want to know how many zeros there are. I might go equals. And whenever I do a formula in Excel or Google Sheets, you have to start with equals. I'm going to do the count if. So I'm counting something counting if it's zeros. So the range, I'm going to grab this part, comma, I want it to be 0. That's my count if it's 0. So it's going to count everything as a 0. There's 2 of them. Here I'm going to do count if, again, same range. If it's 1, count them. So it's counting all the ones. There's 9 ones. Count if. Twos. And I'm going to try to drag this down, except I'm going to have to change these. So you can drag down. To drag down, you kind of go to, you have this little black crosshaired X, and then you can left click drag, and that copies it down to other ones. Oh, I have to change what it is to B2. And I want this to be 4. And this one should be, if it's 3, you can go into the edit box up here and change that to the number you want. How many 6s do I have? I'm just going to do it. I have 2 6s. All right, so I might go into it. So here I've got 2, 2, 9, 4. Oops. 2, 2, 9, 4. Okay, and one person had 8. Oof. All right, so, one second. 8. One person had 8. All right, so this is a way of displaying my data, because reading something in raw form is just not very practical. Right? It's hard to really get a feel for the information and see it just off of here. So we summarized into a table. We organized into classes. So classes are distinct groups that are different groups. Like 0 is one class, 1 is another class. So 0 is the class of all people who have 0 siblings. 1 is the class of all people who have 1 sibling, and so forth. So how many classes do I have here? Don't forget the 8 down here. Count him too. What do you guys think? Okay, so I got a lot of people. Yeah, so 8 is very common. 7, some people think 7 too. If you count them, 1, 2, 3, 4, 5, 6, 7, 8. Here's the thing. I go 0, 1, 2, 3, 4, 5, 6, 8. I can't do that. I have to add in what happened to 7. So I have to have a spot for 7 to go. I can't get to 8 without 7. So I have to put in 7 with a frequency of 0, and then I'm good. Does that kind of make sense for people? So really there are 9 classes, because I have to have a class, this class of how many people have 7 siblings, 0 of them.
Professor Young,
Yeah.
wouldn't it be considered like maybe false data if it's like, if there's no group 7 and there's going to be like any siblings?
Well, that's why you have to have how many people have 7 siblings, 0 have 7 siblings. It's not, I mean, this tells you how many people are in that group. So there's 2 people who have 0 siblings, 2 people who have 1 sibling, 9 who have 2 siblings. The frequencies tells you how many people are in that class, in that group.
Okay.
Yeah. Right, yeah, no, good questions. So I want you guys to think about this for next class. What if it's impractical to have each value have its own line? For example, how many days a year do you drink coffee? You could have 0 days a year or 365 days a year. That's the most you could every day. But you can't have 365 lines or classes. That'd be way too many, right? So what can we do instead? So think about that. For today, your assignment is to turn in page 2. So you need to download page 2, upload page 2 into your assignments, make a copy of it, take a picture of it, save it as a PDF, and upload it here for participation credit. This is this is not homework. This is just proof of participation. That's all it is. So we did this page in class. Just go ahead and take a picture and upload it to prove you're here. That is it. Have a great day. Sorry I went over a little bit. And I will see you guys all. Have a good weekend. We'll see you guys all on Tuesday.